All right. Hopefully you guys can hear me, and I've got the stream up here looking at some of those comments. So if there are some issues there with the audio, let me know. Obviously, this is the first time that we've done this, so if we run into some technical issues, we'll work on it as we go. So I'm excited to do this. My name is Ross Eld, a meteorologist here at 13 ABC, and I've done hundreds of school talks in my career. I love doing them, and this is the first time we've ever done something like this, a virtual weather talk in this format, but given the circumstances, we thought this would be kind of a neat thing to do that might be able to help out some of those kids that really love weather or science or earth science, or maybe for some of you parents that want to try to provide some sort of educational tool to the kids. So what we're going to be doing is we'll talk today about the severe weather awareness. Actually, we'll talk about it today. We'll talk about it tomorrow. And again, coming up on Thursday. And this is Severe Weather Awareness Week in the state of Ohio. And so we figured we'll focus on severe weather this week, and then we'll go from there with some of those other topics, and we'll get to that come up. Actually, I think I got a slide showing some of that. So today we'll talk more about tornadoes, the how, the why, what's behind it. And also, I realize that tornadoes are something that scare a lot of kids. There's something that scared me when I was young, when I was in first and second grade. And the more you learn, the more you understand about these tornadoes. Obviously, it can be very dangerous. We know that. But there's a lot of reasons to not be fearful of them, and so we'll talk about that. Coming up tomorrow, wind and hail, and then we'll talk all about lightning, which I love lightning. I think it's a fascinating topic, so we'll get to that on Thursday. And then next week, we'll talk about earth science, so volcanoes and wildfires and stuff like that. So we're going to keep running through these topics. As long as school's out, we're going to be here. We're going to be doing this. So yeah, comment, let us know where you're at here and how things are going. And I've got the stream up here. And by the way, yes, we're in Northwest Ohio here. We're going to talk about Northwest Ohio stuff. But if you've got friends or family or somebody across the country that is in a similar boat, share the link with them. Let them know. That's fine. I think all this material is going to be certainly good for them too. I don't think it'll be a problem if it's somebody across the country. So hello from Adrian. Good to see you, Ashley. Good to see you there. Nancy, good to see you too. So we're going to go ahead and talk a little bit about just kind of the beginnings here of what it takes to get a tornado, what it takes to get to that point. Tornadoes are incredibly rare. You can comment if you want. What's something, even right now, a lot of us are locked up at home. Maybe we're doing a little extra cooking. What's something that you like to cook? What about cookies? If you're going to put together chocolate chip cookies, what are some of those ingredients that you would put in those cookies? Would you put in sugar, flour, broccoli? Would you throw in broccoli? Well, probably not. I don't think that's probably going to get you what you want. So you have to have the right ingredients and get those chocolate chip cookies. And when we're talking about tornadoes, we have to have the right ingredients to get a tornado. And it starts well before we ever get to that point. So first we've got to have clouds, and we got to have the right type of cloud that's in the atmosphere for us. So this is a cumulus cloud. We would get this typically when the air is really warm and it's humid. So that's really the first ingredients that we have to have. So think on a summer day when it's really hot and it's really humid out, and you start getting these clouds that develop here in the sky, and they don't go up very high, but if they can continue to move up into the top part of the sky, and we can get this big cloud to form, that's our first ingredient. Now, this is just like a typical shower for us, right? So there isn't anything scary about this at all. This happens almost every single day in the summertime. We get what's called fair weather cumulus clouds that build for us. But to take this cloud and turn it into something that's a little bit stronger, you got to continue to have that warm and humid air. It gets taller and taller. But a typical shower doesn't cause any trouble at all, because all of this warm air goes straight up into the cloud, and it forms that cloud. This is like our fuel. That warm and humid air is like that fuel that builds up that cloud top. And then when it starts to rain, it comes right back down, and that rains cold air, and it basically shuts off the fuel supply altogether. And so a typical shower, typical thunderstorm only lasts about 20 minutes, 30 minutes, maybe 40 minutes in the summertime, and then that's it, and it's gone. So we have to have something that's going to take the magical ingredient. It's maybe for our chocolate chip cookies, it's the chocolate chips that's in it, but it's going to take that magical ingredient to take this little shower and turn it into something that's much stronger. So this is what happens if the air just goes straight up like we were talking about, and then it comes straight back down. It just kills that shower, kills that thunderstorm, and it does not last very long at all. So we have to have the winds that are going to be a lot different in the atmosphere for us to get severe weather. And so that's what we're looking at a lot of the time when it comes to severe weather forecasting is we're looking for the ingredient for the winds kind of turning and twisting with height. And this happens a little more often in the springtime. And so a couple things happens. One, these winds come in really strong in the top part of the storm. And so when these clouds start to go up, they start to tilt over a little bit. And so now all that warm air is coming in at an angle and the rain's coming down at a different part of the storm. And the other thing too is that you might notice here that these winds are coming in at different directions. And so because of that, it can kind of twist those storms all around for us. And that's where we start to get some more issues. And so this is a big, mature, severe thunderstorm. This is what it makes it look a lot different here. And then just your typical shower. And you can see you've got the little tornado there towards the bottom. You've got the wall cloud here, right in this part of the thunderstorm, which is where all the severe weather is at. All that warm and humid air is getting drawn up into it, comes all the way up, kind of punches a hole at the top of the cloud. It's so strong. The rain and the hail comes down. It's in a completely different part of the thunderstorm. And now this thing can go and live for a long, long time. So it can just continue to build and build and build and pick up all that energy as it moves across the landscape. But you have to have all those right ingredients. So just like if we're going to bake chocolate chip cookies, if we don't have our flour or butter or sugar, all that good stuff, right, all that yummy stuff to make the cookie, it's not going to work. We throw in spaghetti or we throw in broccoli. I don't know. I've never tried a cookie like that, but I don't think it's going to work out too well. So let's take a look here. This is a different graphic, but hopefully visually it kind of shows how a tornado would come together. Again, we have to have all the right ingredients, and you get those surface winds that are moving in the one direction, much stronger winds just in the top part of the storm, and it begins to create kind of this rolling tube. We can't see it, but basically it's an invisible rolling tube, this rolling column of air that's spinning around. And that happens even when we don't have a thunderstorm cloud. It's just the winds being in the right direction at that point. But once that cloud comes together and it's in this environment with these ingredients, then it can start to be a problem for us. So then the other thing happens is that when we get that really strong, warm and humid air and it rises really quick, and that's what forms that thunderstorm, well, that updraft, we call it an updraft of that warm, humid air. It can take that and it can push that column of air straight into the sky. Still not a problem, right? This doesn't look like a tornado. It's just kind of a swirling horizontal tube of air. But then as it begins to go straight up into the cloud, now we have a problem. And here's the great thing about tornadoes, if there is a good thing about it. Obviously, they're very scary and they can do a lot of damage. But the thing about tornadoes is that this whole process takes a lot of time. It doesn't happen in 15 minutes. It takes 15 to 20 minutes just to get that shower kind of going and turning into a good thunderstorm. It takes more time for it to grow and grow and grow. And then by the time this thing turns 40 minutes, 45 minutes old, and this whole process starts to play out, there's a lot of warning signs that we can look at to actually see the rotation inside this thunderstorm before it ever forms a tornado, which helps us as meteorologists be able to put out a warning and to go on TV and let you know that there's the potential for a tornado before it even develops. So that helps give us quite a bit of lead time and helps us out. But then inside the middle of that storm, the rotation happens first. It kind of works its way down in the form of a wall cloud. And then eventually, if all the ingredients are still there, it can come down into a funnel cloud. And then if it touches the ground, then it's a tornado. So you've got a long process that goes on here just to get that tornado to even form to begin with. When we look at severe weather, the Storm Prediction Center they are like the go-to source. They have lots of information. Let's just say it, the best severe weather experts in the world are out in Norman, Oklahoma at the Storm Prediction Center. They've got an amazing amount of smart people that are looking at all of this stuff. But they also put out a severe weather forecast each and every day. And it has 5 different levels to it. And so sometimes on TV we'll talk about there's a chance of severe weather, but it's a slight chance or it's a marginal chance. Well, here's all those chances kind of laid out on the screen. And you get into that purple color. That is very rare. Might only happen 1 or 2 times in the United States once per year. And that's at high risk. Moderate risk is that level 4, and that's really rare. We haven't had that happen here in Ohio in a long time. Enhanced risk, we might see that here in Ohio maybe once a year. In Northwest Ohio, maybe once or twice a year. We'll get several marginal or slight risk days. And notice at the bottom there, it talks about when we do get those marginal or slight risk days, usually the ingredients aren't as strong to give us that tornado. So maybe we don't get them to happen that often, or they're not quite as strong when they do happen. So that is certainly something that we kind of look at for those different risk levels. But it's not just severe, or it's not just strong tornadoes. It also has an indication for hail and wind, which we'll talk much more about later on for tomorrow. But certainly there's a lot that goes into it once again. So I'm going to go back over here and talk. I want to show you something else too, because if you look across the country, depending on the day, we talked about how we have to have all those right ingredients come together at the right time. So bear with me here. And I'll get off clear the board here. But this map is going to run through basically every week. So it's going to go through this 52 times, going through a whole year. But this is the chance of a tornado across the country. So here we are in January. This is February. Watch how it's starting to grow, right? And the brighter the colors, in fact, I'll go ahead and I'll pause this here. So this is April 22nd. And notice that big bullseye right out there in the middle of Oklahoma. Actually, the Storm Prediction Center that I was talking about that does all this, they're right here. There's a reason for it. They're right out in the middle of that bullseye because there's a lot of severe weather, a lot of tornadoes that happen in Oklahoma. This is really kind of the bullseye for the whole country. But this is April 22nd. And notice how we're barely on the edge of this, even in late April here in Northwest Ohio. And if we expand it out, turn that off here. We go out, you can take a look here how that severe weather risk starts to increase a little bit. Whoa, that went really quick. Let's see. All right. We'll stop that. Let's see. Well, now it doesn't want to do anything for me. Let's see what we can do here. All right, so now we're back all the way to December. We're kind of backing things up. But you can see this is May. And this is June. This is usually when that severe, so the warmer it gets, what's happening here is the reason that moves northward is that you start getting hotter and hotter weather. The cold air continues to go farther and farther away. So that big battle zone where all those ingredients are starts going a little bit farther north. And for us, it also begins to include us a little bit more. This is in June. June's one of our bigger severe weather months that we've got out of the whole year. And then as we go later into the summer, it begins to drop off. So this really is kind of the peak of our severe weather season. It's late May, June, going into July. And this is also a look. I figured we'd probably get some questions when it comes to how strong some of these tornadoes are. I get these questions a lot when I go out to schools, but they go anywhere from this 0 rating, this EF0, all the way up to 5. And 5 are those EF5s, those are the strongest tornadoes that we have that get recorded here. And that's when you get in the 200-mile-per-hour range. In fact, it's really kind of hard probably for you to read at home, but over on the side here it says, when you get up to the 5, strong frame houses and high-rise buildings have significant damage at that point. Even it can take trains and kind of toss them off the tracks. And that's one of the reasons why, and we'll talk more about safety and severe weather safety here coming up in a couple days, but this is the reason why we want you to go to the middle part of your house, getting in a bathroom, into a basement, a storm cellar, because if you get a tornado this strong, it can do a considerable amount of damage. But the good news is that this is incredibly rare, and sometimes it doesn't even happen in a severe weather season. These weak tornadoes, these zeros here, the ones, these happen much more than all of the other tornadoes combined. We usually just have some weaker tornadoes. But again, they can be certainly strong and do quite a bit of damage, but it is that's that whole scale that we look at. So while it goes from 0 to 5, 5s are really rare. Tornadoes are really rare. They don't happen that often. Even here in Northwest Ohio, we typically get maybe a couple tornadoes in the whole area in a given year, and that's pretty much it. So when it comes to, looking at, that risk area, that is something that we certainly take a look at quite a bit. I'm going to leave it up to you guys now with questions, whatever you may have when it comes to tornadoes. I'll try to load up here. Maybe you've already asked some questions, and let me get things loaded back up, and I'll take a look at what we've got here. Why does the sky turn green before a tornado? And this actually has more to do not with the tornado, but it has more to do with the hail, believe it or not. So when we get these large hailstones into the cloud, when the light comes through, it ends up kind of bending those light waves, and you end up getting the color green is what you end up seeing instead. So kind of like if you look out on a rainy day, that you might have gray or really kind of blue clouds begin to approach. The reason that it's that color is because the really fine raindrops that are in there are kind of, again, bending the light, kind of changing things a little bit. So you see that gray and that blue, but hail, it's bigger, it's a different type of deal, and you end up seeing more of that green typically with that. And the strongest thunderstorms that produce tornadoes typically also produce hail, not in the same spot as a tornado, but it's in a different part of the thunderstorm, but it does produce it, and that's usually why you see that green. So that's definitely a scary sign when you see that. It usually means there's severe weather. The thing is, though, you can have a green sky, and it doesn't always mean there's a tornado with it. So, and usually most of the time it doesn't, but definitely usually means that there's hail along with it. How fast can tornadoes get? So they can move, if we look at the speeds here on the tornadoes, they can rotate in a circle 200 miles per hour or stronger. Now, those are those really strong EF5s. We've had some of them closer to 240, 250 miles per hour. That's spinning around in a circle. As they're traveling towards you or away from you, tornadoes could be as fast as sometimes 50 or 60 miles per hour. So basically like driving down a highway in a car, they can go that fast. Although usually they don't go quite that fast, but they can. Sometimes they can actually be stationary. It all has to do with how fast the storm is moving and how fast the winds aloft are pushing that storm. So typically they move at about 20 to about 45 miles per hour. So is typically how fast they move, but they spin around at anywhere from about 60 miles per hour if it's a really, really small, weak tornado, all the way up to about 200, 250 miles per hour. What area gets the most tornadoes? This is certainly out towards Oklahoma, northern Texas, southern Kansas, and they get a lot. That's at traditional Tornado Alley is where we typically see that. In fact, speaking of traditional Tornado Alley, I think I can answer that actually a little bit better. So let me get back on the right slide here. So let me go back over to the PowerPoint presentation that I had up here and take this off. Okay, so this isn't the best looking map, I realize that, but it does kind of point out what's happening here. So right here, well, let's get a different color. Let's see what we can do here. We'll go with green. There's no green on this map. Maybe it'll stand out. So this is Northwest Ohio right here that I just circled in. So that's where we're at. You can see we're kind of in that yellow, orangish shading. So it's kind of the middle of the scale here. But then out in the middle of Oklahoma, look at that big bullseye. That is really the target. This is not only the tornado hotspot in the United States, this is the tornado hotspot in the entire world, without a doubt. But Tornado Alley itself extends up into parts of southern Nebraska and goes down into northern Texas. And I would even throw in parts of western Missouri and western Arkansas. Actually, I worked in western Arkansas, right down in this corner here, for about 3.5 years. And we had some big tornado outbreaks down in that area that, unfortunately, that we forecasted for at times. So it was a big deal in severe weather season. But then notice how the deep south here kind of has its own alley. This zone here is actually called Dixie Alley, is what they call it, down in the south. So Arkansas, you've got Mississippi, Alabama, Georgia, Tennessee, which has had that big tornado that was around and in Nashville itself. And while we're kind of on the edge of things, we still have a fair amount of tornado activity, but it's nothing like what they typically get out towards the west. What causes the hook in the radar? So the hook in the radar, that's a really good question. In fact, let me see if I've got another image here that might help us out even more. Let's see, here we go. All right, so this, and I'm going to need a different that you can see that I was circling here on the one side of your screen. Now that hook in this part of the storm, it was, so right here is the hook. Well, kind of green, let's see. All right, we'll use blue. We'll try that here. We'll see how that works out. But that hook in that storm is right there. Notice how this is where the hail is in this purple up in the northern part, and then all the winds are circulating around that circle where it's kind of empty right in between, and that is where the tornado happened. And we know that Well, not only by looking at the damage afterwards, but we could see that on the radar by looking at this right here. This is kind of like almost like an X-ray. So if you were to break your bone, and you might have to go to the doctor and they take a picture of your bone and you look at your leg and you can see where it's broken. This is like our X-ray to look inside the storm, and we can see the movement of the winds with those raindrops. It scans the raindrops, figures out how quick and fast they're moving. And when you get really bright green and really bright red next to each other, you know there's a lot of strong rotation, and that's what they were measuring there. And so you see the hook and you can see where the rotation is on that storm, and that was certainly that was a big tornado that ended up forming with that particular storm there. Let's see, some other questions here. What's the most tornadoes that we've had in 1 year? Stacy was asking about this. And I'll tell you what, I'll give you two answers to this. One, the exact answer is the Storm Prediction Center will have that information. It's a great website. So that is SPC, as the Storm Prediction Center, but it's right around 2,000, somewhere in that category. And we had, let's see, 2003, but 2004 was a particularly bad year. Obviously, we know 2010, 2011 were pretty active severe weather seasons around here in this part of the country, in Northwest Ohio also. Are tornadoes, great question. Riley, 8 years old, asking, are tornadoes always whitish in color? Not always. So they're whitish a lot of the time because of the air pressure inside that funnel is lower, and so basically you're getting a cloud to form inside of that tornado. Believe it or not, that whitish part of the tornado, that's only the inside of the tornado. The strong winds are actually on the outside of it. So sometimes if a tornado isn't picking up a whole lot, or if it's just a funnel cloud, sometimes we can't actually see the winds there. We just kind of see the inside of the tornado, which is pretty neat. But it's not always white. If the tornado does pick up a lot of debris, a lot of dirt, it could be black. Down in Georgia, they have a lot of that red clay. If it were to pick that up, it could be red. And for us, a lot of the time in Ohio, we get what's called rain-wrapped tornadoes. And there's so much rain kind of rotating around it that it just can't, sometimes you can't see it at all. And that's, we definitely try to tell people, don't go out looking for this. Tornado warnings issued. You want to go to your safe spot towards the inside of your home, wherever that may be. Basement, storm shelter, closet can certainly help. How big can a tornado get? Cheryl was asking on this, and Amber's got a good one too. Do tornadoes always spin in the same direction? I'll answer Amber's real quick here. The answer to that is no, they don't. Usually it's counterclockwise, but so we talk about cyclonic, so counterclockwise, but it can be the other direction. Does not happen very often, but it can be the other direction. So tornadoes on size, how big can they get? Typically, an average tornado does, believe it or not, only lasts a few minutes, sometimes only seconds. And they're usually fairly weak, EF0 and EF1. And you're talking about winds, 60 miles per hour up to about 100 miles per hour, does minimal damage. And they might be the width of a football field. That would be your typical tornado. And we get a lot more of those, and we get strong, violent tornadoes. But the largest tornado that I can recall, and I'm not saying this is a record, but when it came to the widest ever, this was out in at least of my knowledge, and what comes off the top of my head was El Reno, Oklahoma. I think it was 2013. It was certainly several years ago now. And that was a very bizarre tornado because it was we talk about all the ingredients. Well, on this particular day, all the ingredients were basically off the charts. It would be like if we had a whole ton of sugar, a whole ton of butter, and a whole ton of chocolate just sitting there for our chocolate chip cookies. There was a lot of ingredients. It was a bad day. Forecasters knew that. But as this tornado developed, it expanded. It was like a mile wide, but expanded out to 2.5 miles wide, 2.5 miles wide, and then kind of contracted again. And so that was a very strange setup with that particular tornado. As for distance, I believe the Tri-State tornado still has the record, or at least close to it. I remember there was another tornado. It was 2012. It was mid-March, and it went from, I think it was around Wichita, Kansas, somewhere in Kansas or northern Oklahoma, and went all the way up just south of Chicago. There was a tornado, or several tornadoes with that particular supercell. That was a really long-lasting supercell. So sometimes they can last a really long time, and they can get really wide. but that's really a rare thing. It usually doesn't happen too often. Terry saying El Reno 2.6 miles wide. Yeah, that, and several subvortices were nearly half mile wide. Absolutely, there's so much research done on that tornado. It's certainly an interesting one to study. Trapton, is a waterspout the same as a tornado? Great question. So by definition, yes, it is. With that said, usually meteorologists will talk about a tornadic waterspout or a non-tornadic waterspout. And what they mean by that is that waterspouts, when they form, they don't form this way that I was just showing you. Tornado goes from the middle part of the cloud with the circulation, it rotates, and then it slowly kind of works its way down to the ground and then eventually touches the ground. Waterspout is totally different. It's out over the water, obviously. They're very weak. They're not like a strong tornado. They're generally very, very weak. But what happens is that you get a really strong updraft because the water is really warm, and you get it when cold air moves right over the lake. And so because the water cannot cool down nearly as fast as the air above it, all of a sudden you have this huge temperature difference that you would never get if it was just land and the air above it. And so what happens is you get these really strong updrafts that form. And updrafts are the air that goes straight up into the cloud, and that's what helps form the cloud. Well, when that happens, if you get any little circulation near the ground, it stretches it out and pulls it up towards the cloud, which may not seem like a big deal. But if you've ever seen an ice skater and they're kind of circling around a little bit, and then they pull in their hands and their arms, or their hands, their arms, and their legs, they pull everything in together, and they really speed up really fast. Well, that's the same thing that's basically happening. When you stretch the area of rotation and you pull it all the way up towards the cloud, it ends up speeding up. And so a waterspout starts on the water, and then the rotation goes up into the cloud, to where a tornado, the rotation starts in the cloud and works its way down to the ground. So that's the difference between a tornadic waterspout and a non-tornadic waterspout, even though if you look at the definition, you could classify everything in the same boat, I suppose. But they are different on how they form, no doubt about it. Let's see. Can a tornado be really small? Yes. Sorry, that one comment just was there, and then it was off again. But yeah, they can be very small. Sometimes, maybe 100 feet, which may seem like a really long distance, but they can be really small. Sometimes they kind of touch the ground. It might be a funnel cloud. It kind of briefly touches the ground and comes back up and does minimal damage, and it can be very small in that regard. Let's see, what does a tornado look like from the inside? Not a whole lot of descriptions from people being able to kind of see this from the inside, but from what descriptions that we have, it's kind of fascinating, but some of the reports that I've read is that it doesn't smell very good. Why that would be the case, I'm not entirely sure. But basically, it takes on, the look of the inside takes on a look depending on how large the tornado is and then how much debris it's picking up. But usually it's just a very chaotic mess of things swirling around is what it looks like. How far can they go? Tornadoes can go, usually they don't go that far. Usually they go maybe a couple miles or something like that. That's a pretty typical tornado, but they can go 30, 40, 50, 60 miles. Sometimes there have been cases where it's been well over 100 miles, but if you just go back to that Nashville tornado, or one of the tornadoes that they had there in Tennessee, I can't remember the exact length on that, but you were talking about a very long-tracked tornado that was with that. Actually, a couple long-tracked tornadoes with it. Evan wants to know when the last time a tornado hit Michigan. I'd have to go back and look at the dates. I know there were a couple weak tornadoes in Michigan last year, but I can't think of the specific date, the strength, and exactly where that was located. Last time a tornado hit Sylvania, it's been a while, but there have been tornadoes that have hit Sylvania. I mean, you had the super outbreak where the tornadoes were definitely close, and there was, I can't remember. We've got a really interesting book, and if anybody out there is just a big weather nut like some of us here, and you are in the state of Ohio, anywhere in the state of Ohio, and you love historic weather events, take a look at the book that's called Thunder in the Heartland. An amazing book. It's got so many stories that go back about 200 years anywhere from blizzards to extreme weather events. It's all about extreme weather events for the most part. But I remember, and I can't remember the date on this now, so I guess I'm not answering that question very good, but it was talking about a tornado that did end up going into what it would be now basically just south of, through parts of Sylvania and ending up close to central and Holland, Sylvania there. But this was back before when it was all farmland, and so it really didn't have much of an impact. So again, you're going back, I think, 100 years or something along those lines, but that's going to bother me now. I'll have to take a look at that book and try to find when that happens. Lindsay says, when do tornadoes strike? And I guess the best way I can describe that is whenever the ingredients come together at the right time is when they strike. And typically that is, for us, that happens more often than not during the late afternoon and evening. And it usually happens during our severe weather season, which would usually be late May, June, and early July. That's the most likely time for it. But we've had tornadoes in November. We've had severe weather in February and March before, but usually it's a little bit later in the season. Let's see here. So how long can a tornado be? So tornadoes, I mean, they're very long. They can go up a couple thousand feet into the cloud, if that's kind of what you were looking at there for that answer. When a tornado comes down, would there be a tornado warning? So almost always yes. I mean, that's the whole goal with it. Now, what happens more often than not is sometimes we get a tornado warning that comes out, but there isn't a tornado that actually develops. And the reason that sometimes that happens is that everything, remember, it's all the right ingredients have to come together, just like we're going to make chocolate chip cookies. But what happens if we throw, what happens if we throw sugar and flour into, mix it all together, and then we cook it, and then we add the butter and chocolate chips? And we're still not going to get our chocolate chip cookies, not like you typically get them, right? So not only do we have to have the right ingredients, we have to have it come together at the right time, and it has to stay the right ingredients all the way through this process. So we got to have the clouds form, we got to have the big thunderheads form, we got to have the right winds in the cloud, we got to have the rotation in the middle of the cloud, and then it lowers, and then it's a funnel, and then it's a tornado. Well, the tornado warning usually comes out when, so we have the image here up on the screen, but when you see, let's see, I'm maybe pointing up here, if you could see where we've got the green and the reds coming together. That's a scan in the middle part of that cloud that's showing all that rotation. And so that's what forecasters are going to look at. The fine folks at the National Weather Service look at these radar images, and when they see that rotation there, that's when they issue the tornado warning. But there isn't a tornado yet. So if the ingredients aren't right over the next 20 minutes, or the ingredients aren't right below that cloud as that rotation begins to develop, then we never get a tornado sometimes. But the reason that tornado warning comes out at this point is because we know that maybe 40, 50% of the time, 60% of the time sometimes, that we know that there's a tornado that could develop from it. And so we want to make sure that everybody gets warned with as much time as they possibly can to get to their safe spot. Let's see here. Okay, here's some good questions. Why do tornadoes mostly happen during warmer weather? So the warm weather is kind of like the sugar in our cookies. I mean, we can get it. We can probably get the ingredients, not probably, and we can get the ingredients on a day like today to get a tornado, but it would be really, really tough to do so because we need warm and humid air, and the air outside right now isn't all that warm. So that means the air above it would have to be really, really cold to get a lot of instability. And so it typically doesn't happen that way. So we normally see that warm and humid air kind of coming in together in those late spring, early summer setups. Can you get tornadoes during a blizzard? I don't want to say it's impossible because we've seen some weird things happen kind of with some winter and severe weather mixes at times, but it would be incredibly difficult for that to happen. And part of the reason is that not only do we warm air and humid air is less dense than cold air, and cold and dry air in particular. But warm, a lot of times when you got a blizzard, you've got cold air that's wrapping in on the backside of a storm. It's cold, dense air, and there's no instability with it. Warm and humid air has a lot of instability. It likes to rise, and it likes to start to create some of those towering clouds and eventually a thunderhead and kind of get the ball rolling all together. What was Ohio's worst tornado? Ohio's had some bad ones. Boy, oh boy. I would have to, boy, Ohio has had some really bad ones. I would have to go back to, I'll answer it this way because there are a couple tornadoes I could say off the top of my head, but I'll answer it in this way instead. The super outbreak in 1974 was absolutely devastating, especially down towards the Dayton area and just outside of Dayton, where that was one of the tornadoes I was thinking about, a strong F5 that just absolutely devastated a long track during that storm. But it wasn't just that tornado. There were a lot of tornadoes in Ohio on that particular day because the ingredients were really high. The other is, and there are tornadoes I could specify with this one too, but I would say the Palm Sunday outbreak in 1965, and that one impacted Northwest Ohio more dramatically than the super outbreak of 74 did. My goodness, it seemed like every tornado that developed on that day was a devastating one, but there was just a lot of ingredients coming together at the right time for that. Yeah, the Xenia tornado during the super outbreak, it was the one that I was referring to just outside of Dayton. That one I think is still probably the on par for the worst, but that tornado that went through North Toledo out to Point Place in 65 definitely ranks up there as one of the worst that Ohio's had too. That was pretty bad. Let's see here. Is the saying red sky at night, red sky at night, red sky in the morning true? So the saying red sky in the morning, red sky at night, sailors take delight, red sky in the morning, sailors take warn. That actually does have some truth to it. That has been around for ages. You can see it in the Bible. You're talking thousands of years ago. This was a saying that actually had some weight to it. And it's still, there is science behind it, believe it or not, because a lot of times when you have a red sky in the morning, you've got clouds, sailor take warning, you've got these clouds that are moving in. The clouds that produce the red sky are typically high or even mid-level clouds for those most brilliant sunrises. So it indicates that you usually have some troubling weather and some rain generally on the way. So there is generally some truth to that. How does hail happen? I'm going to go into a lot of details on this tomorrow, so I don't want to dive too much into it today. Let's see, probably a couple more questions here, and then we've got to get off because we've got a weathercast. We've got the noon show coming up here. Let's see. All right, looks like some of the questions that I had here are maybe potentially even frozen up. So, but the hail question we'll definitely get to later on tomorrow. Can a tornado form by humans? That's a good question. I don't, while we can create a lot of tornadoes like in a lab in a controlled environment. We can create, if we got 2 bottles and taped them together and put water in it, we could create, swirled around and create our own tornado and do that here too. But that's obviously kind of in a controlled environment. Out in nature, I don't know. That has not been attempted. There's been more research on if it's possible to stop a tornado by trying to, warm up certain parts of a cloud or something and try to disrupt that flow. But I have not seen any research on how to create a tornado. But anyways, I'll leave it at that. Tomorrow we'll talk all about wind and hail and then lightning and severe weather coming up on Thursday. So hopefully you liked it. If you got some other questions, certainly leave it here or ask them tomorrow. It's all the same severe weather. It's all the same topic. So we'll get to that at that point. I enjoyed it. Again, we'll see you guys tomorrow.